Angle properties of circle. Property number 5. The tangent is perpendicular to radius. Tangents of circle. What do you mean by a tangent? Tangent means a line that touches the curve at the one point of contact. Now, by property, tangent is always perpendicular to the radius at the point of contact. Meaning, if I have the tangent over here, PQ, this one over here, and the radius OA, I will naturally get a 90 degrees. If it's not a 90 degrees, it will not be a tangent. So in this case, angle OAQ is 90 degrees. Now, because of this property, we can come up with property number 6, which is related to the tangents of circle. The abbreviation for this property is tangent perpendicular to radius. Angle properties of circles. Property number 6. Tangent from external points are equal. As a spin-off of the previous property, tangent is perpendicular to the radius. Let's take a look at this diagram over here. I have two tangents being drawn from the point P. And the first tangent is AP. If this is a tangent, that means it will be perpendicular to the radius of the circle at A. And next, we will have another tangent from the same point P to touch the circle at B. That means this point here, this tangent here, will be perpendicular also to the radius. Now, let us add on a little bit of drawing. Draw a line from O to P. What do you notice? I have two congruent triangles where the radius is the same as the radius, this common length, and they have a right angle each. So this line OP cuts it into two congruent triangles. As a result, the length over here BP is equals to AP. That's why the question says, the property says, tangents drawn from the same external point are equal in length. Now, that means, in this case, BP will be equals to AP. There are many spins off from this property. Number 1, notice that OBP, A, and go back to O, I have a quadrilateral. What is the angle sum of quadrilateral? Angle sum of quadrilateral is equals to 360 degrees. Notice I have a 90 degrees over here. I have a 90 degrees over here. If I have the angle BPA, I am able to find the angle BOA over here. The second spin-off from this property is, if I were to draw a line from B to A, I will have another different triangle, ABP. What do you notice about this triangle? The two tangents over here are equal. So what makes what will this triangle become? This triangle now becomes an isosceles triangle. So if I were to have the angle over here, what will I be able to find? I'll be able to find the other two angles. So that is base angles of isosceles triangles. Now let's try to apply this property into answering some of the questions. Take out the following worksheet again. Now take a look at the following questions. Before we begin, let us have a quick recall of all the different properties that we have learned. The first one, property number 1, a Chinese dancer. Angle at the center is twice angle at the circumference. Let's take a look. Do you see a Chinese dancer anywhere in this diagram? Yes, I have BOA, where the Chinese dancer does a split and then she stands up to touch the circumference of the circle. Next one, angles in the semicircle. Do I have any angles in the semicircle from this diagram? Not that I can see. Number 3, the butterfly, angles in the same segment. Is there any angles in same segment down here? No. Next one, angles in opposite segment, the cyclic quad. Do you see any cyclic quad down here? T cannot be considered as a cyclic quad because it's not on the circumference, so don't have. But next, do we have tangent perpendicular to the radius? Inside this diagram, TA and TB are tangents. That means the angle A here is 90 degree. This one over here is also 90 degree. And they are both tangents from a external point, T. So based on property number 6, tangents from external point are equal in length. So let's mark this down. Okay, and they tell us that angle TOC is a straight line. And angle ATB, the whole angle, is 80 degrees. The question asks us to find angle ABT. ABT. What do you see? I noticed that there is a isosceles triangle where the tangents from the external point makes it isosceles. So how do I find angle ABT? I shall take angle ABT to be 180 degrees minus 80 divided by 2, and that gives me 50 degrees. Base angles of isosceles triangle. The reason that we have used down here is tangent from external point. Number 2, find angle AOB. What can I find? I noticed that a spin-off from my tangent property, OABT, this is a quadrilateral. I have a 90 degree down here, a 90 degree down here, and 80 degrees. Now angles in a quadrilateral adds up to 360 degrees. So for part 2, I'm going to use the property to find angle AOB. 360 degrees, subtract 90, subtract another 90, the two perpendicular, subtract an 80 degrees. And that will give me 100 degrees. Angles in sum of angles in quadrilateral. Number 3, find angle ACO. ACO. Oh, this is angle at the circumference. Now, earlier on, we have already identified the Chinese dancer. Angle at center is twice angle at the circumference. So in this case, angle ACO will be just 100 divided by 2. And it gives me 50 degrees. Have you gotten the answer? Now we have come to the end of all the different properties. We'll be doing all the different questions in the next few lessons. Stay tuned for more lessons. Have a nice day.